Question 3. So it's asking, how do you convert the parametric equations into Cartesian equation, a single Cartesian equation, by eliminating the parameter r? So here they give you x is equal to r squared plus r. And they also give you y is equal to r squared minus r. So basically, our goal here is to get rid of the r's completely and just have an equation that contains x and y. So we can do this in a couple of different ways. I'm going to start by rearranging each of these equations that, since we notice that these both have an r, they also both have an r squared, but we're going to start with this. I'm going to rearrange for r so that I can set them equal to each other. All right, so y minus r squared equals, I'll write this the other way, r squared minus y is equal to r. Okay, and I'm going to set this equal since they both have r isolated. So if r equals to r, we have x minus r squared is equal to r squared minus r. And now I'm going to rearrange so that we have r on one side of the equation and then only x and y on the other side of the equation. So rearrange, we have x plus y is equal to r squared, and then we have r squared is equal to x plus y divided by 2. Okay, now that we have r squared, I'm also going to try to find out what the product of x times y is. And that will help us sub in for r squared. I think you'll be able to see a little bit better what I'm trying to say when I show you. So from the equations that we know, we'll sub in x and y. So this is x times y. That's y. So we're just going to do simple multiplication with brackets. So r4 minus r cubed plus r cubed, and last one here is minus r squared. So r cubes cancel each other out because we have plus and minus, and we're left with r4 minus r squared. Okay, so since we already found out what r squared is with x and y, we can rewrite this as r squared to the power of 2, which is, as we know, the same thing as r to the power of 4. And then that way we can sub in r squared with what we found out before here. So that's x plus y divided by 2 squared minus x plus y over 2. I hope I'm not cutting too much off here. Okay, so, well, the denominator, we have 2 squared, which is 4. And then I like to think of the little saying, square the first, square the last. And then in the middle, we have the first times the last and doubled. Minus, y divided by 2. That just stays the same. And don't forget we have an x and y on the other side. And then, because we have 4 in the denominator and 2 in the denominator, we want to get rid of denominators completely, so we're just going to multiply the whole thing by 4. So we have 4xy is equal to x squared plus 2xy plus y squared minus, well, if we multiply this by 4, this becomes 2, right? Oops. So 2x plus y. Alright, now we can rearrange because, as you can see, we only have x and y left. So we have our final equation. We're just going to set it, rearrange it and set it to 0 so it looks like a normal Cartesian equation. So we have x times y on either side. So moving that over, we have 0 is equal to x squared minus 2xy plus y squared, and then I'm just distributing the minus 2 into the bracket, and we have minus 2x minus 2y. Alright, and that's your final equation. Of course, you can rearrange that if you have like a preferred arrangement for where to put the x's and the y's, but that is what we've got. Just checking the answer here. And we have all the same terms. We have x squared, y squared, minus 2x minus 2y, and minus 2xy is equal to 0. Great. Let me just leave comment. Okay. Good work. Correct solution. Okay, on to the last question for today. All right. This question asks, find the values of x for which the series, the given series, converges. And then it asks to answer the question in interval notation. All right, so what we are going to do is compare this given series with one that we already know. So we already know about the geometric series. I'm just going to write it down here so that it'll be easy to compare. So the geometric series is the sum of n1 to infinity, a times r, power of n minus 1, which is equal to a times 1 plus r squared plus r cubed plus etc. r to the power of n, n minus 1. And we know that this series, the geometric series, converges when the absolute value of r is less than 1. Okay? So what I'm going to do here is try to write out the given series so that it looks similar to this geometric series, so we can confirm if it converges like the geometric series does. So this is the series that we are given in the question, to n, and we can start to write out the sum. So at n equals 1, which is where we're starting, according to the notation, we have x minus 3 squared times 2, and then if n is 1, it's just 2, plus the next term where n is equal to 2, we have x minus 3 squared to the power of 2 plus x minus 3 squared over 2 to the power of 3, and of course we know that goes on and on. Okay? So we can see that we can take out something common between all of these. So we see that the x minus 3 squared is common between all of these, but it also has 2 in the denominator, which we can also take out. And then we are left with 1 plus 1 over 2, because of course 2 squared is just 2 times 2, and 2 cubed is just 2 times 2 times 2. So we can take one of those 2's out from each denominator, and this is what's left over for this one, so that's 1 over 4, or you can also write that as 2 squared, plus, and then etc. basically. So you can kind of see that this, what we just came up with, that wasn't really a line, what we just came up with here looks very similar to what we determined up above, right? Just rewrite this over 2, 1 plus, if we say that 1 over 2 is r, then we'll have exactly this equation. All we have to do now is replace 1 over 2 with r, and this first value here with a, and then you'll get the same equation as the geometric series. So we can confirm that it will behave in the same way. That our series, the one that is given in the question, will behave the same way as the geometric series. So that means that it will converge when r is less than 1. Oops. R is less than 1. And we know r is, well, I'll just write it like this. R is less than 1. Kind of redundant, I guess, but 1/2 is less than 1. So makes sense. We know that this is a geometric series, and we can say that it will converge when r is less than 1. It's asking for the answer in interval notation, and this interval notation, I guess that's absolute value. You can write it in that way, or because it's absolute value, it's equivalent to saying this. So when r is greater than -1, or r is less than 1. Since absolute value, it allows for both positive and -1. So this will be the final answer. Oops. This will be the final answer, and we know that our series converges when r is in between the values of -1 and 1. So I think that's all we'll be covering for today. So if you found this video helpful, please leave a like. And if you want to be notified of when we do another Q&A like this one, just hit the subscribe button and the notification bell. If you want to submit any of your own questions, you can see the links in the description, or just leave a comment below. And that's all for today. Thank you.